It gets worse.
Hard act to follow.
So a few things before I start. In the past 3 months, I've had about 5 cups of coffee. 3 of those were this morning. So, hey. Also, if you've seen Jason Bell's talk earlier on, you're about to get essentially the Fisher-Price version of that talk. And I can't for the life of me imagine why anyone would want to ask questions after this, so don't be worried about trying to ask questions if there's a weird, awkward silence and I'm sitting here looking sad or whatever. It's okay, don't worry. Catch me after if you have a question, but we're not going to hang around for too long. Okay, so I'm going to start with a history lesson. Kind of at the first half of the 20th century, there was a man called, and I'm going to try and get his name right, Reuben Garrett Lucius Goldberg, commonly known as Rube Goldberg. He became famous for drawing cartoons that sort of featured really complex machines that did really simple tasks in kind of overly convoluted ways. It's a common term, but a lot of people will have heard of Rube Goldberg machines. And this is one of the sort of famous examples. This is Professor Butts, yeah, that's his name, and his self-wiping napkin. So as you can see, instead of just wiping it himself, he's got this crazy machine that does a lot of crazy stuff. To bring the board games bit in, if anybody remembers back to their childhood, they may remember the game Mousetrap. In the game Mousetrap, you kind of went around the board. I'm sure they still sell it. I'm not entirely convinced, but you go around the board, and you, as you go around the board, you build this kind of machine in the middle. It's like got like a diver in a bathtub. It's got this like helter-skelter thing with a ball at the top of it, and it's got this kind of like trap set at the end. And eventually, once you all get around to the end, somebody ultimately triggers this machine. It causes a domino effect to go down. The diver jumps into the bathtub and knocks this thing down, eventually hitting this yellow pole that you see, which is that red thing's at the top of it, and it goes do-do-do-do and shutters down. Anyone underneath that is out of the game. That was the theory. If anybody actually remembers it and hasn't managed to block it out of their memory, it never worked. It basically either broke halfway in between, or you couldn't set it up properly. All the bits were usually missing after the first go. It was actually a terrible game, but it's full of nostalgia, right? So that's an example of a Rube Goldberg machine as well. An example that's kind of more close to home for us is obviously any sort of our systems architecture that we have. Microservice architectures, they're just Rube Goldberg machines. Enterprise architectures from, I don't know, for the last 30 years, they're all essentially Rube Goldberg machines. They do ultimately simple things, but they do them in really overly complicated ways because you all got to get money, right? So that's another example. But obviously, why am I talking about this? Well, it's kind of to set the scene, or set a bit of context about what I'm about to talk about. So long story short is, I wanted to get some data out of a website, so I wanted to scrape it, and ultimately ended up building what is essentially my contribution of a Rube Goldberg machine to the world, this overly sort of engineered thing. It's not that I'm saying, go ahead and do it this way, this is the right way. It's probably the worst way to do it. But to be honest, there are things that I learned that are applicable to like hobby projects all the way up to kind of like big, massive data scraping pipelines. They're very kind of fundamental things. A lot of them probably seems like common sense, but I mean, I did this thing, so I may as well talk about it, was my kind of theory. So this is to the start. We're starting now. We hadn't started yet, if you hadn't guessed. I like board games. I like playing board games. I like collecting board games. I like playing with other people. They're playing their board games. The whole thing, the art is all different. There's so many interesting styles and things. It's really, really geeky, but I just absolutely love trying to hunt down the next really interesting thing, be it the way the pieces are painted, the concepts that are employed, the mechanics, just all this stuff just really, really attracts me to board games. It's just like big boxes of cardboard that I stack up. Other people collect vintage cars and all that stuff. I just burn money on plastic or on cardboard. But the thing about board games is things like Amazon and Google, you go in and you just type board games in and you get things like Mousetrap or Monopoly, which is the worst game ever. And you get standard card games, things like that, poker. Type of board games, you get poker options. I mean, they're not the same thing. So it's kind of very, very hard to track down the really good and interesting board games. There are some sites that you can go to that are news sites, and you can see up and coming ones, but kind of there's thousands upon thousands, tens, hundreds of thousands of games out there. What are the good ones and what are the terrible ones? So there is a site which is the font of all knowledge. If anybody watched Parks and Recreation, that's a Parks and Recreation in joke, apparently. But anyway, this is BoardGameGeek.com. BoardGameGeek is essentially the Wikipedia of board games. It has a lot of games. There's about 100,000 board games on it. And as you can kind of see from that screenshot, if you can read it, there's descriptions, photos. You can see all the mechanisms employed by the game, the family of games that it is, adventure or whatever, the type of game, categories, ratings, players, length of time it takes to play. All that kind of really, really, really good stuff is on that site, and it's really good to sort of click through. It's kind of an old site. This is this one page that when you're looking at a game, it's kind of themed using new CSS. The other stuff is essentially like SharePoint version 1 kind of list view stuff. It's a really old PHP form framework. It's just a big beast of a thing. And I mean, it's good. It functions. It works. That's brilliant. But a website is only a representation of the data that's behind it. And unless your website gets really, really, really complex and really, really, really convoluted and offers a lot of crazy features, there's only so many types of queries you can do. Sure, I can go and I can look at the category of civilization. I can see all the board games associated with that. I can click through and I can see designers and artists. But there are some questions that I kind of, when I have data and I have a thought in my head, I want to ask that it's not a straightforward kind of, I'll go to this page and do this. It's a more complex query. It's about the relationships between things. And that's when websites kind of fall down. And that's when you want to kind of understand those things, you have to do something a bit different. And that's where I got to, being a bit weird and wanting to kind of understand things like relationships between games. So here's the master plan, right? We have this lovely site, do something with it, get all the data out of it, store it in a format that I can run queries over the top of it and find out really weird and interesting facts about games and statistics and stuff like that. Sounds like an easy plan, right? Well, the problem is it's not, and this is the point of this entire talk. So plan A seems like the most straightforward. Most people who work with kind of data and sites and stuff like that there will kind of go, okay, we'll just scrape the data. That's absolutely perfectly fine. But you may remember that I did say that this was a really old PHP forum framework thing. And this was before things like semantic HTML was a thing that people actually cared about or thought about. This is before things that where CSS1 was just like not really that mature, and you didn't have 2 or 3. And it's just styling things with CSS was just not a thing. Back in those old days, we used to use tables. So if you actually look at any page on this site, even the game pages or just the list pages and stuff, they are just tables nested upon tables within tables and tables and tables, just all over the place. There's no styles applied to them other than the table rows and table cells and stuff have specific styles added to them, but there's no CSS style attributes or class attributes added to the actual tables and elements themselves. So actually scraping data out of these becomes more, instead of going, give me the thing with the ID of board game, with the title, with the name and all that stuff. You're basically saying, give me the 7th table within the 4th table, the 3rd cell of that, the 7th cell of that, and it becomes really, really, really painful to do. It's painful if it's predictable. It's impossible if it's inconsistent. Every single page on that site produced some subtly different way to represent the tables or the data that's on it. So it was really hard. And to top it off, when you start nesting things like tables and stuff like that, you end up with, like, the page size is really, really big. You're talking, hundreds of K for each page. And we're talking about, I want to get at least 100,000 board games out of this, and I want to do it. And I don't want to use any bandwidth that I may be paying for, and I don't want to just use their bandwidth. It's a bit cruel. So that was kind of my first lesson. So HTML is, or at least can be, kind of messy, kind of bloated, and pretty inconsistent. So in and of itself, it's not necessarily a good way to scrape really old complex sites without going into just some really terrible hacks. It's doable, but it's not necessarily recommended. If it's the only option, do it, or just don't do this at all. Plan B is obviously, does it have an API? Well, actually, yes, it does have an API. It took a while to actually find out the fact that it had an API. It was actually, I think it was because I bought an app from the App Store and I was like, well, how are they interfacing with this? So it turns out they have an API. Very, very hard to find out the fact it has an API, but there is a page that is essentially the entire documentation, and it's very, very, very light on any sort of documentation. It's an old XML RPC API, so it's not self-documented or anything like that lovely new RESTful experiences that we're seeing now. This is just old, just hit a URL with some arcane ID, get back a massive blob of XML. So that's annoying. It's undocumented. It always seems to be the case with APIs. Either people really care about their APIs and you get this amazing documentation that's like interactive and all, it's great, or you just get nothing. There's no, it never seems to be like a middle ground about here's our API, here's some things you can do with it. So that's one thing. It's largely undocumented. But also up here, there isn't actually a get/games. I can't get a list of games from the API. I can get, and if I know a specific ID or a reference to a game, I can get the data for that, and I can get a lovely big massive XML blob of a rich data for it. But there's no way for me to get actually all the games I want to get. If I want to scrape all the data, can't do it with the API. Not directly anyway. That's lesson number 2. Sometimes APIs are really undocumented and they're limited in capacity. So on to plan C. Take the best of A, the best of B, mash it together, get C. Okay? Or in more kind of bullet point form, scrape the IDs from the site. Basically use the HTML. There's a page on the site that gives me like all the games. Scrape the IDs from that. Get the game data from the API using those IDs, map them to a data store, query the data store, and just, you're done. You're happy, you can do whatever you want. Sounds simple again? No. So, stage 1, get the IDs. Let's talk about this. So for a start, this kind of implies that it's one big list. It's not. It's a 981 page it's 981 pages, this list, and it's ordered by either title or user votes. There's no way to create, like, there's no way to say, give me all 100,000 things in one thing. It's basically stuck at, here's 100 documents at a time. So that presents a bit of a problem. And let's kind of visualize that. So you've got a red and you've got a green game, okay? So I want to scrape one of those pages, rip out all the IDs, okay? So I come along and that's the page there. The red's in it, green's not. And I'm sitting there and I'm sitting scraping that page. In the meantime, while that page is being scraped, something happens. Something like somebody, I don't know, votes for this game, or a new game comes in, or something happens, which essentially causes a reshuffle of a couple of games. So as green has actually come in while I've been scraping it. Now, it's come in on the server side. I've already downloaded that HTML page, and I'm scraping it there and then. It's come in, and I then immediately go to page 2, and I start scraping that. 2 things have happened. I have double counted the red one. That's fine. I can deduplicate things because I assume all their IDs are unique and they don't randomly change. But I've actually missed the green one. Oh, okay, I've missed a board game. Big wow. Okay, but there are certain situations, especially when you're using third-party systems, that the data that you're using is kind of volatile. So that's kind of the third lesson. You need to consider that data is often volatile. It's subject to change. And when you read it, there's a very high chance that it's probably stale at that point. And you can probably deal with that. In my case, I can deal with it. I don't really care. This is a hobby project. But kind of the big lesson is obviously, if you're in that situation, you need to scrape it quickly. You want to get a snapshot. You want to narrow that little window of time where I'm basically going in between 1 and 2. I want to make that as sort of minimal as possible so that changes do not happen. So I want to create a snapshot really quick. So there are ways to do that. Obviously, parallelize the scraping of the pages, define how many pages I want, scrape all 981 or whatever it is pages at the same time. That presents a slightly different problem, which I'll get onto in the next bit. Or do as little as possible in the scraping of the pages. So basically, grab the page and do it offline. Take the contents offline completely. Don't actually bother trying to process it at that point. Process it later on. So do it offline. So that's stage 1. We now have 2 components in our little pipeline of scraping stuff to get into a data store. We have the page scraper, which downloads the HTML of the pages, does something with it. We've got an ID scraper, which takes the contents of the pages that I've downloaded and rips the IDs out of them. So that's kind of the first stage, which leads us on to our sort of first design decision, or kind of other than we're going to build a pipeline, of course. How do the components communicate with each other? I haven't at this point said that these are running in the same, they're both in-process things, or they're a big microservice architecture, they're running in the cloud, or running on a local machine. I'm trying to keep this as abstract as possible. I wrote this thing actually to be even more similar to JSON stock. It's actually all written in Clojure. But that's neither here nor there here, other than you'll see a wee bit of kind of pseudo Clojure code here, but it's fine. So how do they talk to each other? It's a pipeline. You want isolation. You don't want to think about, okay, these are running in process, we'll just call them. Or, actually what we need to do is we need to scale them up and, we need to have more ID scrapers than, page scrapers and stuff like that. You need to keep things isolated, isolated and independent. So you got this thing where you got the page scraper that's sitting there doing its own thing. It knows how to reach out to the site, and it knows how to grab these things. It has to do something with them. At this point in time, the ID scraper's stuck. It can't really do anything because it's got no IDs to scrape. It doesn't know how to talk. When you want to keep isolation and you want to keep things happy and you want to keep things completely independent so that you can scale them up or scale them down or do whatever you want with them, one of the most fantastic, simple data structures in the world is the queue. Queues are great. Now, queues have their own things you need to deal with. Yes, at massive scales, you don't want to have unbounded queues and nonsense like that. And there are a lot of things to consider. But at this most primitive level right here, we have a queue. So the page scraper comes along, grabs a page HTML, dumps it on the queue. This little bit of thing comes along. This is not how queues work. This is just a little bit of animation I tried to put in. Comes along, ID scraper super happy, grabs it, starts gobbling it up, does whatever it needs to do with that ID, waits for the next one, and it keeps going. As long as things keep being put on the page queue, that's going to keep listening on the page queue indefinitely, and it will run completely isolated. So that's lesson number 4. Queues are great for isolation. You don't have to care about what you want to talk to or how many things you're talking to or coordinate or even have to have them running at the same time or in the same system. And they're really, really great for fault tolerance as well. So if the ID scraper dies for some reason or I take it down, the page scraper doesn't really care. It's just going to keep putting stuff in the queue. Now, assuming your queue is persistent and you have nice queue semantics wrapped around the things, then you're going to get, even if the queue goes down, you're kind of going to be okay. So, stage 2. We now have all the IDs sitting in a queue. We then want to get the data. We're done with the HTML, we're done with the web page. We now want to use the API itself. Okay? So in its most basic form, forget about the fact that this is Clojure or kind of a Lispy syntax. This is a data scraper. While I have an ID to get, while next ID returns an ID, for example, while I have an ID to get, download the next thing, download that ID. So that download next thing is it's an expensive operation that goes out to the thing and downloads it. Now, that in its most basic form is okay, I guess. The problem is, if I have like 1 million or 100,000 IDs primed, this thing is going to start churning through them. If I have more than one of these running, it's going to start churning through them as fast as it can. And there's a problem there. I'm using a third-party system, and if you're scraping data from a third-party system, people do not like you basically taking the piss. Okay? If you're going to sit there and start scraping as many pages as you can, they're going to have things like modsec stuff, things like that built in, modsec security, stuff in Apache or Nginx or whatever. It's going to go, oh, okay, this one IP is trying to deny the service me. I am just going to basically start returning 503s for a short period of time, keep it up, and I will blacklist your IP. So what you want to do is introduce some sort of throttling. Now, this is the most primitive throttling you can do. This does not scale very well, and it's just not great. But as a concept, you want to throttle your stuff. You don't want to basically take the piss and abuse other people's services. Talk to them, find out what rates and stuff that they have, and work with them. And if you can't, just kind of do a sort of very small trial by error going, well, if I do it every 1 second, they're not going to complain, that's fine. It's going to take a long time to download 100,000 things, but that's okay. So that's lesson number 5. Bad things happen to bad people. Treat other people on other systems with respect. Okay? So let's look at this again. What happens if download next thing is an expensive, let's pretend it's an expensive operation, it's got network involved, it's got bandwidth involved. That's sort of sitting running there, and it runs every 1 second. But what if the third-party system goes down for maintenance for 3 hours? These data scrapers are going to sit there, they're going to run hot for 3 hours, not really do anything. If the timeout there on the download next thing is, say, 40 seconds, they're going to sit and they're going to block for 40 seconds. If this is part of like a big chain of things, you're going to have issues. So this is where circuit breakers come in. Circuit breakers are a resiliency pattern. I think originally from the Release It book, I could be wrong there, but they're well documented in the Release It book. And these are kind of useful little things. So there's us and there's them, no relation to politics. And we're making a lot of requests to them, okay? And we're downloading their stuff. Now they go down for some reason. They don't go down in a really nice way where you make a call out to them and it immediately fails. It's one of those ones where their process is hung so it just sits there and eventually your timeout kicks in and the connection's killed. So your system is sitting there going, oh no, well, I'm just sitting here, what am I doing? What's going on? Blah, 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 blah. that's fine if it's a one single process, but if, as I kind of mentioned, if you have like a microservice architecture kind of thing where you have 4 processes doing things in a chain or something, all those things are going to time out and say they're all 40-second timeouts. They're all going to have these 40-second timeouts, and that's a lot of resources that are being consumed for this one request. If you have a lot of requests happening at the same time, they're all going to just sit up and eat resources, and you can eventually run out of memory or run out of connections or do some terrible thing. And you can actually get massive cascading failures across your system. Not in this case, but in bigger cases. So that's where circuit breakers come in. Circuit breakers wrap calls to external services, or sort of fragile calls or expensive calls, but essentially a lot of external services. And they're in one of three states. One of three states. They're either closed, which means that any call that goes through the circuit breaker to your service, it just goes, it's fine, it comes back and it gets sent back, and the circuit breaker kind of ignores it. But then when it gets tripped, it goes into this open state. So say a request comes in, the request comes in, flows up to the other system, times out, or it returns some sort of error, and it comes back. The circuit breaker then goes, oh, right, okay, whoa, stop here, and just carries on. It stops, it doesn't stop everything, but the next calls that come in to the service, the circuit breaker immediately stops it there, fails fast, and goes, no, you don't have anything to do with that. Now you can control how they fail. You can either throw exceptions, or you can have status checks or whatever in your code, but it doesn't do the expensive operation in this state. So it just fails fast, really quick, no resource contention, no long timeouts, no waits or anything like that. Then after a certain configured period of time, and it's all for sort of technology dependent, this kind of stuff, it goes into this other state, this half open state. Essentially what goes in is it's still open at this point, but one request that it allows through. And if that request still dies because the site's still down or something like that, it goes back into the open state and then goes into a little cycle of open, half open, open, half open. But if it comes back successful, it just opens up again. So in that period of time, you're not getting a lot of massive, like a lot of failures or timeouts or resource contention. It's just everything's feeling fast, and you can be notified of it. There's lovely metrics for things like circuit breakers and stuff. And so that sort of makes our our generic data scripter a wee bit bigger. Essentially, this download thing ID, that is the expensive operation. It's wrapped with this circuit breaker called download circuit breaker, and whenever that thing throws an exception, it trips. So that's our data scripter has now got more sort of complex, and that kind of leads us on to lesson number 6. Bad things happen to good people. So be prepared. I have to go a bit faster. Okay, so CS3, we mapped the data. We've got all the data. We've downloaded them as XML files onto our system. Technology decision. How do we want to store this stuff? Okay, so this is a game. Games have relationships with other things like mechanics and types and designers of the games and publishers of the games. Even the published relationship there maybe it was published in the year 2000 or 2010 or whatever. That's one game. There's loads of games with all these different relationships all over the show, and there's more interconnectedness there. That's a graph, okay? So it's the relationships that I'm interested in. So I map it to a graph database. I use Neo4j because I know it and I've used it. But ultimately, when you start looking around the world, you'll see lesson number 7. Graphs are everywhere, and they're a great way to model relationships. Okay, SQL is fine, but you end up, if you have to map a lot of if relationships is your key thing, you end up with a lot of really complex hyper-normalized schemas, and it's really complicated to write joins and things like that. Graphs are designed specifically for this. But there's more. I have a bunch of XML files now downloaded in my system. Is there any benefit to having a massive index blob of XML? Do you know what? There might be. Why not? Who knows? It depends on what you have and what you need. That's the lesson number 8. You got data stores. There are various choices of data stores, not just the one big SQL world now we live in. NoSQL, SQL, big table, all this nonsense. We've got loads of them. And it's very hard to make a decision unless you really, really know what you want about what stores you want. And there's a lot of really immature ones. So finally, stage 4, we now have the data in our stores. We want to query it. Neo4j, we use Cypher. Cypher is a bit like SQL, but it's got relationships built into it. So I can say, where designers have designed this board game where the name of the designer is Ralph, give me the name of the board games for the top 10 ones. There we go. You get a nice UI like that, which lets you see pretty pictures and do query things. BSX, XQuery, that's what I stored the XML blobs, the XML into, this thing called BSX. It lets you write XQuery, which is actually a really good language. I know XML is terrible and people hate it and things, but XQuery is a massively great functional language. Everything's a list. It's fantastic. You can do like big stored procedures and stuff like that. Nice pictures like that. And that's where we have our big massive data pipeline. That's what we've got for just scraping a website for a hobby project. So that's lesson number 9. Time is finite. Don't waste it doing terrible things. And that is me. You can get me on Twitter, Tinder, GitHub, whatever. There you go. Did I do it in time?
Yes.
Seriously, I doubt there's questions. Is there questions? No. You're going. Bye. Yeah, that's me. I can take questions if people want questions. Is there questions?
For questions, if anybody else has anything.
You got to do a scalability test?
Nope. It runs on my Mac. Hey. It scales to my Mac.
That's great. Thank you very much.
Conclusions from the data?
I didn't really use it. I have it. I never really finished scraping it, to be honest. I kind of got about 30,000 in and kind of give up.
Okay, thank you very much, James. Thank you. Impressive number of words per minute there as well, I think.